Alright, today we're looking at similarity for triangles, and we have used the word similar before to describe triangles or any shape that is the same shape but a different size. So let's write that down for our definition, that we want things that are the same shape but they're a different size. And one way that we can tell this for a triangle, or for other things too, is if they have the same angles. So they will always have congruent angles. The angles will all match. They'll just be different side lengths. So to check that something is congruent, in our box here, we would make sure that all of the angles match up. So what I mean by that is, if I'm looking at these two pictures, angle J that's in the first triangle, you can see it has 2 marks. It would match with angle X. So I'm going to say that they would have the same measure, angle J and angle X. The other angles that would match would be angle K, has 1 arc on it. It would match with angle Y. And then the two that have no marks, angle L and angle Z, they would also need to match and have the exact same number. So like maybe they're both 47 degrees. The other way we can check to see if any shape is similar is see if the side lengths are proportional, meaning they make the same fractions. So if I was looking at a side length on this triangle, maybe I'm looking at JK. The side length that would match with that on the other triangle would be XY, both of the ones on the left. So if I figure out how big JK is, and it's going to be a number I don't know, so I'll just put JK for now, and I make a fraction and compare it to XY, so let's pretend that side is 10 and this side is 5. Then when I make another fraction for another side, maybe KL, the top side, KL is on top of my fraction, and the YZ matches with that side. Though when I make that fraction, it would need to be a fraction that is equal or proportional. So those fractions need to equal each other. So maybe it could be like 8 and 4. Because in that example, if those were my numbers, then my red fraction would be 8 on top and 5 on bottom, equal sign. My blue fraction would be 8 on top and 4 on bottom. Well, my red fraction, 8 divided by 5 is 2. And my blue fraction, 10 divided by 5 is 2. And my blue fraction, 8 divided by 4 is also 2. So they match. The last side that could match with them as well is JL. And from the other triangle, it would be XZ. Notice I put all the sides from the big triangle on top and all the sides from the little triangle on the bottom. We want to make sure we stay consistent with where the big triangle is always on top and the small triangle is always on the bottom. So we're going to look at 2 shapes now and see if they are similar. So if these shapes are similar, we said all their angles would have to match. So that means angle A, if I look at the picture, it would match with angle E. Angle B would need to match with the one in the same spot. That would be angle F. Angle C would match with angle G in that picture. And the last angle, angle D, would then match with angle H. So we would check that they all match. If we wanted to check sides that would match, well, one side I could make from the red one is AB, and the side that would go with that from my blue shape is EF. So I would have AB needs to make a fraction with EF. Another side could be BC on the top and FG on the top. So BC needs to make a fraction with FG. My third side would be CD and GF. They need to make a fraction that is equal to the others that have come before. And last side, AD needs to make a fraction with EH. And all those fractions, once I put the numbers in, need to turn out to be equal to each other. So these are our two ideas. We need angles to totally match and the side lengths to make proportions or make fractions that equal each other. So we're going to check now for an example. Here's two shapes. We're supposed to check and see if they work. Well, I can't check anything about the angles because we don't know anything about the angles. There's no angle numbers given, only the sides. So I'm going to match some sides. If I match AB, the side that's in the same spot as AB is ED. So that makes a fraction of 10 over 15. In my calculator, I could see what is that fraction really equal to, and 10 divided by 15 gives me 0.3 repeating. Now I need to check some more fractions, make sure they're all the same. So if I pick side BC, which is 8, it would match with side EF, which is 12. So my fraction would say 8 over 12, and I check in my calculator, 8 divided by 12, I also get the decimal 0.3 repeating. It's not enough to just check two of them, though. I need to make sure all three match. So let me try my last one. My last two sides are 12 and 18. And in my calculator, 12 divided by 18, I get 0.3 repeating. So we could say, yes, they are similar because sides are proportional. Their side lengths I need to change my spelling. Side lengths proportional. When we made fractions with their sides, they all made the same number, 0.3 repeating. That number doesn't really matter what number it makes as long as it matches every time. We're going to use this idea to also figure out side lengths if we don't know what they are yet. And the way we're going to do that is through 3 different steps. So we've got an example of 2 triangles even in this picture, or in this box. Our first step is to make sure that the shapes are facing the same way. So I'm going to say make the shapes face the same way. So if one's tilted sideways, let's redraw it standing upright so that all the sides match up. Then our second job is to write a proportion or write 2 fractions for the side lengths equal to each other. So as an example, if I was going to use these triangles in this box, I would say that 14 matches with 2 and make that a fraction, and then put my equal sign, and I need to match up the other sides, so x matches with 1. And make that a fraction, x and 1. Notice I'm putting both of the big triangle numbers on top, both of the small triangle numbers on bottom. So that's what I mean by write a proportion, a fraction equal a fraction. Then last thing that we will do for step 3 is we will cross multiply, which is the way we solved fractions equal to fractions, and solve. So it's been a while since we've done that. So let's try an example to make sure this is making sense. I've got 2 pictures below, and they look like they're already lined up facing the same way, so I don't have to do step 1. I do need to do step 2. I need to match up some fractions. So I could match up this side, GF, which is 4, and it would match with this side, which is 3. So 4 and 3 are match. Then I need 2 more sides. FD would match, it's a 3, with x. And I did the big number, big shape on top, so the 3 goes on top and x goes on the bottom. Now cross multiply and solve is step 3. Cross multiply means when you multiply 4 times x, you multiply the diagonals. So 4 times x is 4x. Then we put our equal sign, and then we do the other diagonal, 3 times 3, which is 9. Now I'm solving a regular equation, so I draw a line down and I think about how to get x by itself. So I need to get rid of the 4, and on both sides to get rid of this 4, it's 4 times x, so I should divide by 4. Then I would have x equals 2.25 from my calculator. So the number for x up here would be 2.25 for this side. And if that was the number, then the sides would be proportional, and we could call those shapes similar. Same shape, different size.